Hi Sudrajat, thanks for your email earlier today and your question. Here it is here captured as a picture. Y double dash plus 4y dash plus 4y equals x cubed e to the 3x. And you wanted the solution to this question. Well, the best thing to do if you want to solve this and find out the step-by-step solutions is basically to go into Google Play. And if you type in differential equations, so if you type in that word there and press enter, you'll see a whole array of Android apps come available. These are all mine. The dog's name is Freddy, by the way. And so whenever you see Freddy, this is one of my live worksheets on my widget tools. So this one here is differential equations second order general solution. So if we tap on that one then, basically and scroll down, you'll see that here you can just type in any differential equation second order and any right hand side you want, and you'll be able to get a step-by-step solution. So that can be installed on any Android tablet or smartphone. So if we go to the actual Wolfram Alpha page, where the widget on my developer page here, I've got it come up on a web browser here. So I've entered it at the left hand side. So we've got y double dashed plus 4y dashed plus 4y equals 0. Now we're going to change the right hand side here to x cubed times e to the power 3x, wasn't it? Put it in a bracket just in case and click on solve. Let's have a look at this then. So here's the solution, but we want it step by step, don't we? So let's have a look at the step by step solution then. The input was correct. X cubed e to the 3x was the right hand side. So here's the solution, and we're asked to solve this equation here. Basically we want the complementary function, the yh and the yp, the particular solution, don't we? So basically the yh comes from solving the same differential equation with the right hand side let be equal to 0. And when we've done that, we can write down the associated quadratic equation. So we end up with just lambda squared plus 4 lambda plus 4, which is here. Easy to see, isn't it, that we get that. And then we can solve that quadratic, the associated quadratic, and we get repeated root case, which is case 2. So we can read off the yh solution here. It will be c1 e to the minus 2x plus c2x e to the minus 2x. So there's our yh. Now let's turn our attention to the particular solution then. Now that we've got yh, here we're solving this, so we try a substitution. Since we've got an x cubed, we're going to need x cubes, which are mentioned in the line here, and we also need x squareds, don't we? And we need an x, which is here, and also an e to the 3x as well. So we work all the way down just to ground level, so to speak. Then we need, that's yp, we need to differentiate, so we've got a differentiation of all these terms, some of which are functions of functions, the constituent parts, and these are of course products, so we use the product rule, and we get the dyp dx. And then differentiate once more, and we get d2y, and then we have to substitute these three things back into our original equation, and we can then equate the corresponding coefficients. So we can equate the x cubed e to the 3x's on both sides, and the x squareds, the x's, and just the e to the 3x's, because they're all linearly independent. So here, for example, when you equate the x cubed e to the 3x coefficients on both sides, there's one on the right, isn't there? And when you work out that bracket, there's 25a4 on the left. Similarly, the x squareds are here, the x's are here, and here's e to the 3x coefficients on both sides. The only non-zero one on the right hand side is of course this one here, because that's all the only term we have on the right hand side is one of these, isn't it? So once you've got a4, you can get back to a3, in turn you can get a2, and finally you can get a1. So there's the values laid out there in the solutions, and then we can tie the two things together, yh plus yp, and we can write down the actual answer here. So there's yc, they've called it here, plus yp, and we can put the two together. If you want to find out the solution with initial conditions, then another of my widgets that I put up in Google Play will do the same problem, and you can input initial conditions as well. So I hope that helps a bit, Sudrajat. Here's a sample solution set from a plotting point of view as well. So I hope you found that helpful. And as I say, if you've got an Android tablet or smartphone, then it's a very simple thing just to install this little app, Google Play. Just type in differential equations, and then you can check any problems you got, and you can say show steps here. So all the best then. Thanks for your question, and I'll catch you again sometime. Cheers.